Today's learning target is I can compare and order fractions, decimals, and percents. Today we're going to be working with rational numbers. And rational numbers are basically the kinds of numbers that we've been focusing on. So things like fractions, like right here, terminating decimals like this, or repeating decimals like this, or integers. These are all examples of rational numbers. Today we're going to be asked to compare different rational numbers. So we may be taking a look at number line like this. Now the thing to keep in mind with your number line is the farther you move to the right, the greater your number becomes. So right here they've shown 1/8 and negative 1/8, excuse me, right here, and 3/8. And so we can see based on this number line that negative 1/8 is less than 3/8, right? Because 1/8 shows up here and 3/8 is farther to the right. Okay? It's the same reason that negative 1 is larger than negative 2. Okay? Because it's farther to the right of the on our number line. If I'm asked to compare two numbers like I am here, I have negative 1 and 1/8 here, and I have negative 1 and 5/8. Now I can use this number line here to help me with that. So I know that these two numbers are going to be between a negative 1 and a negative 2. Okay, so when I look here, we can see that this is split up into 8 equal parts. Here's 1, 2, 3, 4, 5, 6, 7, 8. Okay, so when I'm looking, right here would be negative 1. So right here would be negative 1 and 1/8. So that would be this line right there. And then I would have negative 1 pointed out here. Negative 1 and 2/8 would be right there. Negative 1 and 3/8 would be right here. Negative 1 and 4/8. Negative 1 and 5/8. So here's where I'm going to have to put my next mark there. So negative 1 and 5/8 would be right there. Now remember, the fraction that's farther to the right on the number line is larger. So negative 1 and 1/8 is greater than negative 1 and 5/8. So when I'm writing my sign, it would look like that. Now let's compare that to if I had 1 and 1/8 and 1 and 5/8, but they're positive. So here they were negative. Now on our number line, 1 and 1/8. So 1 and 1/8, here again it's going to be between 1 and 2. And this is 8 equal parts split up. So 1 and 1/8 is going to fall right here. So if I were to put it on that line, it would be right here. And 1 and 5/8 is going to fall right here. And now, which fraction is farther to the right? It would be 1 and 5/8. So when they're positive, 1 and 1/8 is less than 1 and 5/8, or 1 and 5/8 is greater than 1 and 1/8. When I'm asked to compare fractions, like I am in these problems, there's a couple of different strategies that I can use, and I'm going to show you those different strategies so you can decide which strategy works best based on what type of problem you have. Okay, so here's an example of a time where I'm going to find a fraction, an equivalent fraction, to help me to determine which one is bigger or smaller. So in this case, I have 12ths as my denominator here and thirds here. Now, if I want to get an equivalent fraction, I can change this into 12ths. And I know that because if I times 3 times 4, I get 12. So if I do it to the denominator, I have to do it to the numerator. So my equivalent fraction here would be 4 12ths. And now I can compare it. I have 4 12ths and I have 3 12ths. So now it's easy to see which of these is larger. And so 4 12ths, or 1/3, is greater than 3 12ths. Okay? If I look at this one down here, I have 5 6ths and 8 9ths. Now I can't get 6 to be 9 by timesing it by anything, and I can't get 9 to be 6. But when I think about these, I know that I can get to 18 by counting by 6's, and I know I can get to 18 by counting by 9's. So I can find equivalent fractions for these, and I can make both those equivalent fractions be 18ths. Okay, so over here I'm going to take 9 times 2, gets me to 18, so I have to times this by 2. So that gives me 16/18. And over on the other side, I know 6 times 3, so I would have to times this by 3, and I would get 15/18. So I can see here 16/18 is larger than 15/18, so I need my less than sign. 5/6 is less than 8/9. Sometimes I can use what I know about fractions to help me know which one's larger. So in this case, I have 7/12. Well, if I wanted to look at twelfths in terms of what's a half in twelfths, well, let's see, that would be 6/12 would be 1/2. Okay, so 7/12 right here is going to be greater than 1/2. Now, when I'm dealing with 18ths, I know that 9/18 would be the same as 1/2. And here I have 8/18, so that's actually less than 1/2. So in that case, I can use what I know about fractions just to say I know that 7/12 is greater than 8/18. However, you want to be sure that you only use this method when you're absolutely certain. If you have any questions about it, you're not sure, you should use one of the other methods. Another way that I can compare fractions, like these two here, is I can turn them into decimals. Now when I look at the denominators here, nothing jumps out for a common denominator, and I don't want to have to count my multiples of 32 and 29. That seems like it's going to be a lot of work. So what I'm going to do is I'm going to change each of these into a decimal, and I do that by dividing. So you can see I've set up each problem here. Now the key with these is you want to make sure that you set up your problem correctly. Okay? So here I have 6 divided by 32. I'm taking 6 wholes and I'm dividing them into 32 groups. Now if I flip-flop this, I'm going to get a decimal, but it's going to be more than a whole number. So it would actually be 5 point something or 5 with a remainder. I know that 6/32 is worth less than 1 whole. So it's got to be a decimal. So I need to set it up this way. Alright, so when I start working this out here, and remember I'm going to use my method over here, did my snake bite, divide first, then multiply, subtract, and then bring down. So 32 will not go into 6, so I'm going to put my right here, just like that. Alright, so 32 does not go into 6. Okay, now that I put the decimal in there, I want to get that decimal here. Now I know that 32 will go into 60 one time without going over. Okay, if I did it twice, it'd be 64. That's too much. So now I multiply. 1 times 32 is 32. Now I subtract. Okay, and I have to borrow. So I have 5 here, 10. So I get 8 and 2, so 28. When I'm finding decimals, I don't do remainders. So what I do is I put a 0 here. Oops, my color changed, sorry. Alright, and I bring down, anytime I need to bring down, I'm just going to bring down a 0. So now it's 32. How many times will 32 go into 280? Here I think to myself, 10 times 32 would be 320. So it's going to be less than that, but it's going to be fairly close to that. 9 I think will be too much, so I'm going to go with 8. So I want to see what 32 times 8 is. I'm just going to do that down here. 16, 8, 16, 24, 25. 256. Okay, I think that's my next number. Here's how I'm going to find out for sure. If I subtract 256, now I should get a number less than 32. So let's see what I get. I'm going to borrow 7, 10. Alright, 10 minus 6 is 4, and 7 minus 5 is 2, so 24. Alright, so that was right. So when I divided, alright, it was 8. Okay, so now, and then I did 8 times 32 was 256, and then I subtracted, and now I bring down another 0. Okay, now at this point I'm going to pause. To find the exact decimal, I need to keep going, but for right now I've got to start, and I'm going to jump to my other problem right here, and I'm going to see if I can figure out which is larger. Okay, so what I'm going to do here is I'm going to divide this out. So I went through the same steps and I solved that problem. Now you can see that I'm actually still going here as well, but I now know which one's larger. Okay? It doesn't matter if these continue on or not, because to figure out which is larger, I just have to start looking at the greatest place value I have. So that's one place to the right here, the decimal. So I have 1/10, okay, and I have 1/10 here. Here I have 8/100ths. Here I have 7/100ths. So this one is larger. You could think of it in terms of money. This is 18 cents. This is 17 cents. So 6/32 is greater than 5/29. When I'm comparing percents, I like to change them into decimals. So 80% to start with, it's going to be 80 over 100, okay, which as a decimal would be decimal 80, 80/100ths, okay. Now I'm comparing that with 805 thousandths. Now when I'm comparing a decimal like this, okay, I have to line up the decimals, and then if I have like this decimal up here, 80/100ths, I can add a 0 after it. It doesn't change the value. Okay, it's just like 8/10 would be like 8 dimes, and 80/100ths would be like 80 pennies. It's the same value. So here now I can see which one's larger, and 805 thousandths is larger. So when I'm ready to compare fractions, keep these things in mind, one of these three ways. I can either use my math reasoning, like maybe I can tell one's more than a half and one's less than a half, so that can help me to figure it out. I can find common denominators for the fractions, or I can turn fractions into decimals.